we are going to take out our highlighter and highlight this. If you have an equation that's factorable, you can write it in factored form. Do you notice that general form, standard form, factored form, they all have the a value in them? That's the one thing in all three forms that stays the same. If something is factored, though, then you have your two x-intercepts. And if you have your two x-intercepts, then you can also get, this is on the next page here, your axes of symmetry. Because your axis of symmetry is halfway in between your two x-intercepts. So I'm going to highlight that. You can highlight that on the bottom of your graph on page 301. And then on the next page, you can highlight these sentences that if you know the axis of symmetry, that's your x-coordinate of your vertex. So if I know my two intercepts, I can find my axis of symmetry. If I have my axis of symmetry, I can plug that back into the equation, and then I get my vertex. And then I could write vertex form. Because as soon as I know my a value and my vertex, I could write vertex form as well. So this provides us with another way of solving our equation. So let's look how we could use this in example 1. I'm looking at this and I'm seeing a bunch of decimals. It makes me initially think, I don't think I'd want to do completing the square with this with a bunch of decimals. It's not actually too bad, but it doesn't look like a lot of fun. Okay? So I say to myself, well, maybe I could factor. And if I want to write this in factored form, I'm going to see if I can take out that negative 2.5 out of everything. Well, that would just leave me with x squared, so that's easy there. How many negative 2.5s in negative 7.5? There's 3 of them. Positive or negative? Positive. And how many in 10? 4. Negative, because a negative times a negative has to be positive. Does this factor nicely? X and X. I think 4 and 1 rather than 2 and 2. I need my outside and inside to make plus 3, so I'm going to make my inside plus 4, my outside minus 1. And so if I set this, technically I'm going to show all my work here. If I make this equal to 0, this will find my x-intercepts. And I can use the zero product property to say that my zeros are at x equals negative 4 and x equals 1. If I was drawing this on a graph, I would know the following. 1, 2, 3, 4. X-intercept, negative 4 comma 0. And x-intercept at 1 comma 0. What's halfway in between those?
Or no?
My axis of symmetry is going to be halfway in between. What's halfway in between negative 4 and 1?
2.5, negative.
Negative 2.5? If I do negative 2.5 right there, it looks like it's closer to minus 4.
Negative 2.5.
Negative 1.5. So sometimes you can check it after, like negative 1.5, that's 2.5 away, and this would be 2. Yes, that matches up better, right? How do you mathematically find something in between two values? That's an average. Right? You get 70 on one test, you get 80 on the next test. What's your average? 75. How do you do that mathematically? I'm going to do numbers that maybe, they're not hard, but it would be maybe a little bit harder to do mental math. 19 on one test, oh, it's a bad test. 31 on the next test. What's your average?
25.
19 on one test, 31 on the other,
25.
25. How did you do it?
Add them and divide by 2.
Right, you find an average by adding two things up and divide by 2. What happens when you add 1 and -4?
-3.
-3. -3 divided by 2 would be -3 over 2 or -1.5. Okay? Which way does this parabola open, up or down? Down. So I know my vertex is going to be somewhere on this axis of symmetry. I don't know exactly where. I don't know. How would I find that point? I find that vertex now. I know that the x value is -1.5. I need to find the y value. So if I take my equation in my original form here, -2.5, I plug in x, -1.5 squared. Was it plus or minus 7.5? Minus 7.5 times 1.5. Of course, this would be a calculator question. Plus 10. If I type all of that into my calculator, what do I get? And I forgot the negative sign there. 15.625. So this point here is at -1.5, comma 15.625, and with that I have enough, perfect, to go and draw my parabola. So, circle questions 3, 4, and 5, and try some of those right now.